Hello, students. Good morning, everyone. I hope you have gone through the previous materials that I have given to you, and please finish your assignment also. I'll update the date in the model soon. Alright, so we'll move forward. To give a heading: Adequacy of rain gauge stations. Adequacy of rain gauge stations. Okay, most of you are traveling today. Okay, I was also surprised why there is so much of a low strength. No problem. Divyam, you have raised your hand.
So for traveling purposes, so
Yes.
uh,
Not getting a clear voice.
sir.
Okay, no issue for attendance today, but those who are at home or those who can join must join as of now. So just give a heading: Adequacy of rain gauge stations. Okay, so we discussed actually a bit about that previously. So what is adequacy in action? Adequacy हम किसे बोलते हैं? Whether the rain gauges are adequate or not. See, if there is a catchment, okay, I hope my board is visible now. ठीक है, last time में मैंने बताया था, if there is a and you have number of rain gauge stations here. Okay. Now you want to know that whether I have installed sufficient number of rain gauges in the rain gauge in a catchment or not, right? So for that thing, there is a set of a procedure which you can follow to know if the installed rain gauges are actually sufficient or if you want some more rain gauges. Okay. So let's write down if there are already some rain gauge stations, if there are already some rain gauge stations in a catchment, if there are already some rain gauge stations in a catchment, the optimum number of stations that should exist with the assigned percentage of error in the estimation of mean rainfall is obtained by a statistical analysis given by n, which here n is the optimum number of rain gauges. It's given by Cv upon epsilon whole square. ठीक है, अभी थोड़ा सा समझिए इसको, ये है क्या चीज. ठीक है, हमने क्या लिखा, विद इन द असाइंड परसेंटेज ऑफ एरर, उसके हिसाब से जितने रेन गॉज स्टेशन है. ठीक है, अभी देखिए है क्या एक्चुअली, अगर मुझे ऑप्टिमाइजेशन करना है रेन गॉजेस का, तो फर्स्ट थिंग दैट आई नीड टू नो for a comparison that what is actually the mean of all the rainfall values or all the annual rainfall values. ठीक है, जितने भी स्टेशन हैं यहाँ पे रेन गॉज के, उन सब का एक मीन लेंगे. देयर विल बी मीन प्रेसिपिटेशन वैल्यू, लेट्स से इट्स p bar. right? Then I'll check with this p bar, which is the average of all the rainfall values, that what is the standard deviation from this mean value for each station. ठीक है, इस p बार से कंपेयर करके देखेंगे हर एक स्टेशन की रेनफॉल वैल्यू को, and we'll find out a standard deviation as combiningly. ठीक है, so that standard deviation decides that what is the variation. ठीक है, स्टैंडर्ड डेविएशन आई थिंक आप सबको आइडिया होगा व्हाट इज स्टैंडर्ड डेविएशन. ठीक है, तो स्टैंडर्ड डेविएशन इज एक्चुअली अ टूल टू डिसाइड द वेरिएशन. ठीक है, तो जितना ज्यादा स्टैंडर्ड वेरिएशन होगा उतना ही ज्यादा वेरिएशन होगा रेनफॉल वैल्यूज का. ठीक है, नाउ से इफ द रेनफॉल इज वेरी मच यूनिफॉर्म, उल्टा लेके देखें अगर कि इफ द रेनफॉल इज वेरी मच यूनिफॉर्म देन द वेरिएशन इज क्वाइट लेस. अगर वेरिएशन लेस होगा तो सारी वैल्यूज जो होंगी हर एक रेन गॉज स्टेशन की जो रेनफॉल वैल्यू होगी दैट विल लाई क्लोज टू दिस पी बार वैल्यू. ठीक है, जितना ज्यादा क्लोज आएगी पी बार के उतना ही वेरिएशन कम होगा और उतनी ही कम वैल्यू आपको मिलेगी कोफिशिएंट ऑफ वेरिएशन की. राइट, सो वी एक्चुअली डिसाइड द स्टैंडर्ड डेविएशन फर्स्ट, then we convert the standard deviation into coefficient of variation, that is the CV. ठीक है, now there is also one another factor, that is the error in the estimation of the mean rainfall. ठीक है, क्योंकि मीन रेनफॉल निकालने का भी एक तरीका है और उसमें भी एरर आ सकती है. ठीक है, because we are going through some mathematical model to find out the mean rainfall, so it can also give some error. So depending upon the error and the coefficient of variation that we got, we can decide this optimum number of rain gauges. Okay, समझ में आ रही है चीज? So see here how it varies. ये स्क्वायर का ध्यान रखिएगा, बहुत लोग ये स्क्वायर लगाना भूल जाते हैं. Even in the GATE there have been questions which have been asked on this particular model. ठीक है, तो ये स्क्वायर का ध्यान रखिएगा. अब यहाँ पे देखिए जो नंबर ऑफ रेन गॉजेस है वो डिपेंड करते हैं कोफिशिएंट ऑफ वेरिएशन के स्क्वायर पर. ठीक है, जितना ज्यादा वेरिएशन आएगा उस वेरिएशन का स्क्वायर टाइम्स ये ऑप्टिमाइजेशन वेरी करेगा. ठीक है, एंड इट इज आल्सो इनवर्सली प्रोपोर्शनल टू द एस्टिमेटेड एरर. ठीक है, so further write down this. You have noted this epsilon is the allowable degree of error. Epsilon is the allowable degree of error in mean rainfall estimation. In mean rainfall estimation, CV is the coefficient of variation. CV is the coefficient of variation of the rainfall values in percentage. Remember, it would be in percentage for the.
Sir, can you please repeat?
The CV.
Yes, sir.
Okay, this is coefficient of variation of the rainfall or the rainfall values. Coefficient of variation of the rainfall values expressed in percentage for the existing rain gauge stations. For the existing rain gauge stations. Alright, so now this CV is decided by 100 times sigma n minus 1 upon p bar. ठीक है, ये परसेंटेज में एक्सप्रेस करने का तरीका है. ठीक है, तो whatever is the ratio of the standard deviation and the mean rainfall, p bar is the mean rainfall, sigma m minus 1 is the standard deviation. This is sigma m minus 1, it is written as sigma n minus 1. इसको minus 1 कोई आपको minus करना नहीं है यहाँ पे, ठीक है, it is m minus 1, it is written as sigma m minus 1, standard notation. Alright, so this standard deviation here, how to find out this standard deviation? इसके दो तीन मेथड आपको मिल जाएंगे बुक में, जो इजी है वो मैं आपको बता देता हूँ. Summation I to m pi minus p bar whole square whole upon m minus 1. ठीक है, this is the way to find out standard deviation. That means we will take each individual value of rainfall as pi and we'll keep on subtracting the p bar. जो भी mean निकलेगा उसको हम subtract करते जाएंगे और उसका square लेते जाएंगे, and we keep on adding this. You can write it like, कैसा दिखेगा अगर मैं इसको expand कर दूं, ठीक है, जैसे p1 minus p bar whole square plus p2 minus p bar whole square up to, suppose there are m number of rain gauges, so pm minus p bar whole square whole upon m minus 1. ठीक है, alright, so this was about the standard deviation. P bar, you all know how to find out this p bar. It is simple arithmetic mean of all the values. So sigma I1 to m pi and 1 upon m. Which is the mean precipitation, right? Now, in case the error is not given, in case it is not given, you can safely take this error value as 10%. ठीक है, अदरवाइज आपको क्वेश्चन में जनरली दिया होता है. ठीक है, तो ये एरर की वैल्यू कैसे डिपेंड करती है? लीस्ट इज द एरर इन फाइंडिंग आउट द मीन ऑफ द प्रेसिपिटेशन, मोर आर द नंबर ऑफ रेन गॉजेस दैट आर रिक्वायर्ड. मैंने बताया था दे आर इनवर्सली प्रोपोर्शनल. ठीक है, okay, just write down an example if you have noted down this thing. A catchment has 6 rain gauge stations. A catchment has 6 rain gauge stations. In a year, the annual rainfall recorded by the gauged areas are given as, तो मैं यहाँ पे stations दिखा दे रहा हूँ. Let us mark that by A, B, C, D, E, F. 6 stations हैं. ठीक है, and let's say there is a rainfall in centimeter. ठीक है, तो rainfall values यहाँ पे हैं 82.6, for B 102.9, for C 180.3, for D 110.3, for E 98.8, and for F 136.7. These are the rainfall values. Now you have to find out the optimum number of rain gauges for a 10% error in the estimation of mean rainfall. Okay, find the optimum number of rain gauges for 10% error in the estimation of mean rainfall. ठीक है, अच्छा एक चीज ध्यान रखिएगा, ये जो अपॉन m-1 है ये इसी अंडर रूट के अंदर है, ठीक है, दिस नॉट आउटसाइड द अंडर रूट, दिस इज इनसाइड द अंडर रूट, सो कैलकुलेट अकॉर्डिंगली. Can you calculate by yourself? Just calculate and tell me the answer. तो मैंने आपको ऊपर से बताया था, पर आपको कैलकुलेशन नीचे साइड से करनी पड़ेगी, ठीक है, इन द अपोजिट सीक्वेंस, क्योंकि लास्ट पैरामीटर है वो सबसे पहले निकलेगा. तो सबसे पहले कौन सा पैरामीटर आएगा? These are my
Pi minus P bar, sir.
P bar, right? So the first value that you will find out is the mean rainfall. How many rain gauge stations? 6 rain gauge stations. So 1 upon m, that is 1 upon 6. Summation of all the PIs from I equals to 1 to 6. Just add on all the rainfall values and divide by 6. How much is the mean rainfall? Please always have a calculator with you whenever you come for the class, right? Because this is a numerical subject. Yes, how much? Yes, how much P bar?
$118.6 centimeter.
118.6 centimeter. All right. Anyone else getting the same answer?
Yes, sir. Same, sir.
Same, right? So we'll assume that it is correct. Next we'll move on to क्या निकलेगा इसके बाद? Standard deviation. We both have PI values and P bar values. So find out the standard deviation then. So how to find that? Summation I equals to 1 to m or 1 to 6, I'll call it, right? Then all the PI values minus P bar values whole square. So keep on adding. Now you can replace this m by 6, so that will be 5, right? तो इसको इस तरीके से लिखिए P1 minus p bar whole square plus p2 minus p bar whole square plus p3 minus p bar whole square up to how many stations are there? Up to p6 minus p bar whole square, right? And whole divided by 6 minus 1. Just put the p1, p2, p3 values from here. This will be your p1, this will be your p2, this will be your p3 up to this will be your p6. Just put all the values, tell me the answer. Aditya Rana will tell. Yes, anyone got the answer? Aditya Rana, you are here? Two 201637. Okay. Sonam 606.
$35, sir.
35, exact 35, or there are some says something beyond the decimal?
35.03.
0.03. You have rounded off this thing, right? If it would be like 035, that will be 04.
Is 04, sir.
04. Okay. Okay, I take it as 04. Anyone else getting the same answer? Anyone else getting the same answer? No? Okay. So, would we be having some unit of this standard deviation? यूनिट होगी क्या स्टैंडर्ड डेविएशन की? Yes, there will be unit or not? Please someone comment on it. There will be a unit for standard deviation or not?
Yes, sir, there will be.
There will be, right? Why there will be a unit? Because see, there is no term like a p term in the denominator. है क्या? नहीं है. So obviously all the values, यहाँ पे क्या है? सिर्फ difference है. ठीक है? So all the values in the numerator will be in centimeter. Obviously this is a square, but if you keep under root on it, it will become a usual centimeter value, right? In practical sense also, if you have to tell someone that what is the deviation of the rainfall, ultimately you are telling a rainfall value, right? If you're talking about a deviation, so I will tell, okay, my deviation is like 10 centimeters, my deviation is 15 centimeters, but it is a deviation of the rainfall, so you will have to apply a unit to it. Okay, so always remember in your exam, because you will be giving on a pen and paper system, writing the units are very important. Otherwise I'll deduct half a mark if you'll not mention the unit, right? All right, so we have got our sigma value. Then can we find out the other parameter? What is the other parameter?
CV, sir.
CV. We have p bar, we have sigma m minus 1 also, and mentioned as a percentage value. Just tell me what is this? This is 35.04. P bar we have calculated 18 point something, right? 18 point, oh okay, 118.6 into 100. How much?
29.54, sir.
29.54. Anyone else getting the same answer? Okay, I hope this will be correct. Right, 29.54%. This is in percentage form, right? So now we can find out the optimum number of rain gauges. So now this will be CV upon epsilon whole square, right? CV we have always mentioned. I told you CV is always mentioned in the percentage form. So now you will keep the value as 29.54. Never keep like 0.029 or 0.2954. This will be incorrect. Okay, you have to always keep in the whole form, in the percentage form. What is our error percentage? 10. So this whole square, how much it is?
8.7, sir.
8.7. Okay, so how many rain gauges we need to install?
Around 3, sir.
3 more. How much in total?
Total, we need 9 more, sir. We have 6.
9,
so
right? We have
yes,
two options now. We have our values in fraction. So either we can go for 8 or we can go for 9. Obviously we'll go for, if we'll go for 8, we'll be short. So better to keep it on the higher side. Rain gauge station cannot be installed in a decimal place. जब भी लगेगा पूरा ही लगेगा, ठीक है? So obviously we'll go for this 9 value. So just write down a total of 9 rain gauge stations are required. A total of 9 rain gauge stations are required. And how much we already have? We already have 6 rain gauge stations in our catchment, right? So how many more we need to install?
3, sir.
3, right? So 3 more rain gauges are required. 3 more rain gauges are required in the catchment. So I hope you have got the system, right? So that perfectly moves on the basis of your standard deviation and mean. Okay, this is all clear to everyone? Anyone has got any doubt up till here? No? All right.
No.
Yes, anyone? All right, so just give a heading catchment area. There are some short definitions that you should know. Maybe I have explained you a number of times, but I'll give a short review. Catchment area, the same thing is called drainage area also. Why? That I told you. Because there is a particular area which is draining into a stream that is passing out. Right? ये क्या है? कोई drainage area या catchment area है आपका? It actually looks like a leaf shaped. Most of the times you will see that your catchment area will look like a leaf, where a stream is passing out from the most lowest reduced level portion. जो सबसे low down portion होगा आपके catchment में, the stream will pass out from that portion. That is obvious, right? So obviously you will see that your catchment has a slope towards your stream in one way or the other. ठीक है, तो यहाँ पे जो slope होगा catchment का वो हमेशा stream की तरफ जा रहा होगा, obviously because this will be a higher portion and the stream portion will be the lowest. So obviously the slope will be towards your stream. Correct? So it is known by the name catchment area, drainage area. Why drainage area? Because all the water is draining from this area and going to the stream. Right? So that's why it is called drainage area, because it helps in providing the water to the stream. Okay? Or it is sometimes also known as drainage basin. Okay? So just write down, it is an area from which all the drainage water passes into one stream or water course right? In US it is known by the name watershed. US में इसको watershed बोलते हैं, the drainage area, right? So always you will see that the catchment area is separated from its neighboring areas by a ridge which is called a divide. So the boundary line of this entire area which separates this catchment from the neighboring catchment, ये वाला जो boundary line है, this is called, क्या बोलते हैं इसको? Ridge. Why ridge? Because usually that will be the topmost portion of this catchment, right? So this will be known as ridge. And it is also called as divide. This is a US word or US terminology, right? It is known as divide. In UK, people call it as a watershed. So rather than calling the entire area as watershed, as in the US system, they call this thing as the watershed in UK. Okay? But in general, watershed is meant for the entire area. ठीक है, समझ में आ गई चीज? So how you will find out this area? अगर आपको ऐसा मैप में एरिया बना के दे दिया जाए तो how can you find out that area?
Integration.
Yes?
Integration.
Integration. There is a simple procedure in surveying. Have you heard of planimeter? Have you heard of this? No, I think you will read in, you are currently in the 4th sem, na? So you will read in your surveying portion. There is something called planimeter. So if something is noted down in a graph, you can find out that area by planimeter. So planimeter कैसे देता है area? So install its one end at one place, and suppose you want to find out the area up to this. So it will give the total area from here to here. Then if you want to go up to here, it will give the total area from here to here. Similarly, you can find out the total area for the entire catchment also. Okay? And according to your scale, you can convert it into a real area. जो मैप का एरिया है उसको रिड्यूस फैक्टर यूज करके आप रियल एरिया में कन्वर्ट कर सकते हैं डिपेंडिंग ऑन योर स्केल, राइट? सो जस्ट राइट डाउन the areal extent of the catchment is obtained by tracing the ridge on the topographic map. Obviously we need a topographic map to show all the topographies. On a topographic map, and measuring the area by planimeter. ठीक है? So I'm just elaborating this catchment. All right. So let's say there is a river A which is flowing down in this direction. Okay, and this is the catchment, which is a leaf form catchment. Okay, so it will have some minor drains first. All the water doesn't go into the river directly. You have some small drains which join the river, right, or the main stream. This is also called river or the main stream. Okay, this thing I'm talking about. And there are some minor drains which actually contribute to this main drain, right? So they will be like this, connecting from all the parts of this catchment. Okay, so what we call them? We call them tributary or tributaries. Right? Why tributaries? Because they contribute to the water in the river or the main stream. That's why we call them tributary. Now even this tributary could have some other minor drainages. Okay? You can sense this tributary as a small river. Okay, and then we have some minor drainage lines also. Okay, which are minor streams. ये क्या है? These are minor streams which collect the water from even the faraway areas. Okay, more will be the number of these minor streams, better will be the collection of the water. More readily the water will go into the river. Okay, so these are very important things actually, because depending upon the number of these minor streams, you can decide that how fast the water will go into the river and how fast a flood situation will occur. Right? So these are actually the collection hands of a watershed, you can call. Okay? So now say if I have to measure the flow of the river at one point, what point should I choose? This point, this point, this point, this point, or away from the catchment? कहाँ पे चूज करें वो पॉइंट को? Yes, anyone? Quickly, we are short of time. See, the river flow is here. If I'll collect the data here, obviously I'll not be able to collect the river flow for the other parts, because as soon as it will move down at this point and at this point, again from this particular tributary the water will start coming, right? So I want a point where all the water from the entire catchment has already been collected, correct? So I'll choose a point here, just outside my catchment, where the entire collection of the water from all the parts of the catchment has already happened, right? So generally the observation point of the flow is made just outside the catchment, where all the aggregation of the water has already been completed. You got the point? So this is the observation point or observation station, which is meant for observing the flow in the river, right? I hope you have understood this concept. ठीक है, ये चीज याद रखिएगा. It will help you in understanding the upcoming portions of the hydrograph also, right? That where we keep this observation point outside the catchment, just outside the catchment. Now obviously in a catchment area, all the incoming and the outgoing water can be shown by the same continuity equation which I told you earlier, which is known as the water budget equation. The water budget equation. Okay, we have already discussed this water budget equation. So what this water budget equation says, that the incoming flow into a catchment and its difference with the outgoing flow, that is equivalent to the net storage in the catchment, right? You may write this equation in a number of forms. In the form of depth, जैसा मैंने आपको पहले बताया था, P minus R minus G minus E minus T, that is equal to delta S. ठीक है, this might be one form. This is the second form, where we mention this flow in the form of a volume. This is incoming volume. Into the catchment. Okay, obviously you have to decide some certain time period also, some delta T time period also you have to decide, in which you are seeing this incoming volume of water and the outgoing volume of water in the catchment. Okay, so incoming volume you can decide with the depth of the rainfall, by the depth of the rainfall multiplied by the area. So that will be the incoming volume, and outgoing volume you can easily decide with the help of this observation station. The difference of that has remained in your catchment in the form of storage, maybe under the soil, over your trees and buildings, or might have been absorbed by the soil and the trees, right? So that is our net storage, what we are talking about. That thing is clear? Obviously this storage also is representative of the same time delta T, in which you have recorded your readings for both yi and y0. Okay, so okay, I'm ending it here. If anyone has any doubt, please tell me now. All right. So we'll meet next on Friday.
Thank you, sir.